Okay, everything should be up and running. Oh, some of these in my chat is gone from Twitch. Did I have to reconnect that? Oh, I have to reconnect that to handle the chat in the room. That's annoying. Yeah, stream key doesn't let me set that. Crap. Wonder if I could do this real quick. It's always a problem, right? We haven't done something in a few days. This all breaks. Oh well. Let's go on for this for now. I'll just have to pop up the Twitch chat here so that I can actually pay attention to it. Yo, what's up, Melly, Melon? Let me pop out this chat real quick. Wow, there's so many things on the chat now. No. Okay. So let me pop it out. Oh, there we go. Okay. That'll at least let me monitor what's going on. Organize all this. Okay. Yo, yeah. Cool. Alrighty. I'm just going to review a little bit of what we did last time. Nothing biggie. Basically, we just supported when we hit a character, it'll flip them around if they're crossed up. That was, and I think, did I do it this? I don't know if I did it during the stream or not, but I had to support a transitioning back into, well, yeah, because they automatically cross up. Well, the other thing I did, well, I'll have to show you real quick, is that basically I went through and added support returning back to idle. Previously, basically, each action would manually go back to idle through a state transition in its own state implementation. But that, doesn't need to be done per state. You want that kind of something handled by the state machine mechanism itself. So you probably can see where I changed this, where it went to like either jump or standing in whatever state this was. What was it? Yeah, like attack. So attack would have to transition back to standing once the timeline had completely elapsed the duration of the action. I removed that. I'm just commenting out there. I should have just deleted it. And I added basically the same code to our state machine handler, state machine manager, whatever you're calling it. All the same thing, yeah. State machine processor. So that's just done here. And if you're in the air, you go to jump, and if you're on the ground, you go to standing. We just say you go back to idle because you can do any action you can do from standing or jumping state from there. The problem is that we have to transition to idle before we do any other action right now. So it gives us an additional 1 frame delay on everything, which is not great. And when we talk about things like frame advantage, what we're saying is like, well, this is how many frames I can start doing my action before the opponent can do their action, right? Positive frame advantage means I can do something before them. And negative frame advantage, which means I have to wait. They can do something before me. And that's going to be equal, right, on both sides. But the math doesn't work out. There's an additional frame delay we have to consider in those cases. So we want to get rid of that. Also, it means you would like come out in action. You're forced to block, right? Because you're going through idle. You can't attack. Because each transition right now incurs 1 frame delay, or it takes 1 frame to transition, right? You transition on the current frame. You can't transition again until the next frame. That's what it means. And I'll just write that down in our schedule. I think that's what I had. Yeah, I'll show how this influences frame of edge. Sorry. It's a little cold in here. I probably should turn off my air conditioner. Whoops. Oh, don't want to spill my coffee. Hope that all made sense. Yeah, so implement the transition to actions directly instead of going through idle first. Through idle, standing, jumping. And yeah, I'll show how this influences frame advantage. To help that, I needed to make like a little debug tool. I'll show that here. Do you see this little like timeline thing up here, right? It might be a little small on your screen, but this shows you how many frames have elapsed since the start of the last action. Right now, this is just idle. We just have kind of arbitrary number of frames. But if I do an attack, you can see, okay, we have a certain number of frames. I probably should show the count at the end. But so we're on the first frame, second frame, third frame, fourth frame, etc., etc. Oops. You can access this by hitting F3. I should have pushed it to GitHub before the stream started, so if you want to pull it down yourself, go ahead. I'm going to just double check that real quick, just in case. I think I already pushed it. Let me move this over. Yeah, I pushed it because it's over here. Yeah, so I made those changes like last week. Yeah, you get all the way to the end, and once you're in the final frame, what happens? So this is the last process frame for the action. You would think you can go to any action from it, but in reality, right now, the way things were implemented, you can only go through idle. So if I press like attack button again, right, you can see that we're clearly in the idle. I don't have an indicator for what state we're in right now, but it's the same number of frames. And then next frame, we get an action. Just to make that clear again, I'll do it again. I'll press a button, right, the attack button, hold it, and we go to idle, and then we go to the action. So that's the problem. We incur 1 frame delay. And if I do it like an attack in the same way, right, we can compare it. So you can see here there is the player. So I should explain this. Top line is player 1, bottom line is player 2. We're on this frame of the action. So what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th frame. And of course, on the reaction, which is going on right now, the player is on their first frame. And right now, the reaction has a set time span, I think. Do we actually implement the hit stun yet? Oh, maybe we did. Maybe I think this might be hit stun. Yeah, because it's 25. So it's 25 here. I should show frame advantage. I haven't shown that yet. But anyway, we can step through. Okay, we're going to get to the final frame. And you can see there's 14 frames of hit stun left, right? Now this is going to be a little confusing. So I would expect basically this to have a negative 14, negative 14 frames of advantage for player, player 2. Or maybe it's negative 13. Let me see. Yeah, that's what it gets confusing a little bit when you're trying to do the math. It's easier when you know the actual recovery time from that point. But anyway. So yeah, negative 13 or negative 14. But anyway, let's count. So normally I would be able to do an action from here. So yeah. So the player still has 13 frames to go through, right? But technically they can't do anything. They have to go to idle first. That's a bug. That shouldn't have happened. I don't know what's going on there. But yeah, basically that's the idea. So we need to fix that. I wonder what that was about though. I haven't seen that bug yet. So it looks like, yeah, then it shows that. That's a weird bug. Let me do this one more time so we can just kind of get an idea. So we're going to wait for the player to go all the way through to the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 frames have elapsed, right? I'm counting each frame that I'm showing, I'm counting in the count. Okay. And you can see hit stun one left here. And I don't know why it's doing this. Anyway. Okay, that's the basic idea. So the problem with it is that we're transitioning to idle directly, and there's no way to transition to all the different attacks. So let's go look how we've implemented this whole like transitioning into action thing, like transitioning to your attacks. That's done in the state machine, individual states themselves, right? If we go down to our common states, there's actually one thing moving on. What's today's date? The 27th? It's been a while. Okay, the 27th, and I'm going to go through and show you this stuff. Common states. There we are. So the way we're actually implementing this right now is, yeah, so we have all this like transition code right here, right? We could either go into, this is, first of all, there's a standing action. So on our update on standing action, this is where we implement all our like neutral actions, such as jumping, moving right, moving left, moving up, attacking. So all these things we can't do out of the last action, right? We're on the final frame of the last action. The next frame will not be in any action we choose. It will be idle. And because this the idle itself is the only place that implements this, it must go through one update, right? But that update won't happen until the next frame. So we incur 1 frame delay. I hope that makes sense. And of course, any questions, go ahead and ask and stuff. That's why we do have the live stream. Okay. So what my strategy here is to move this in a there's 2 things we can do. We can move it into the state machine executor itself, which is a little dirty. We can make like an overall like state transition or state command, action system command thing, right? That when you come out of another action, you check to see if the command's being executed and then immediately go into it. The other strategy is to put individual function calls in each one of our actions, or at least our common action state that looks at the input and then transitions directly instead of idle. So let me show you both strategies and kind of talk about trade-offs real quick, because it's kind of the fun part, I think. So what we're going to do is going to take this code, copy it, make another little common function here. I thought I had more common functions implemented. But anyway, let's just, man, it's been a few days since I programmed in Zig, so give me a second here. Common idle input. Okay, I don't really know what to name it yet. Let's name it that. It needs to be void. And probably we need to do bool so we know for sure that we, or maybe we don't need to do bool. We can just add idle to here, right? Actually, we don't even need to add idle because we handle the idle transition in the most common place. So I'll show you the trade-offs here real quick. So first of all, we'll implement this. It basically does the code we are already doing in idle already, and we'll put that code, say, in the attack, for example. So let's go to, okay, what we'll have to do too is check if it's the final frame, because we don't want to do it unless we're on the final frame, right? So attack here, so we'd have to do it, let's do it on updated. So this is what we were doing before, right? We're checking to see if the frames elapsed has been greater than the duration, and then we did the transition to jump or standing. For now, we'll just do common idle input, or let's just rename it real quick. Let's see. Transitions. So common idle transitions. This means all the transitions we would do from into idle or whatever. Okay, so we'll test that real quick. See what it means. What are the implications, right? Does it work? We'll see. Well, that didn't work because I didn't put a semicolon. That's important. Oh, yeah, I need to pass in context, right? That's important. Okay, hold on. So we need to pass in context. Okay. Does that fix things? Our state machine takes a context, so it knows what's the current character is working with. Man, it's Cops Day. Okay. So let's see how this works. So before, the problem was we'd get to the final frame of an action and we couldn't do anything else. All right, what if I hold the button this time? So let me hold the button so we can see if the action occurs. Nope, we still went through idle. Why did it happen? Well, it's because in our state machine, well, I'll bring that up. Is it in here? State machine. What are the orders? We're always considering like what are the orders of when things are happening, because we're very like single-threaded, single-process game. So what are the orders? What is the order which things get executed, right? because that determines what's priority. Generally, what happens last is priority when we're talking about these state transitions. So actually, in our state machine executor, what do we do? Well, if we have an update function, we run the update, which is, we just looked here, this update function calls this, right? And we do that, it's fine, whatever. But what happens when the timeline, so down here though, we check the frames elapsed already, right? Again, sorry. And then we force a transition into idle. So this is overriding what we're doing in the state machine itself. Okay. So we'll run into these kind of problems quite often if we're not careful, where we want to force a state transition from the state machine, from the individual states, but something else after that executes after overrides it, which is some cases we want, like we want reactions to override any kind of like action transition we've queued up. So there's a few different strategies you can handle this, right? Or ways to handle this. One way is that we can check to see if something's been queued up and not transition to idle, right? So see how we have this like context variable, be transition true? Well, what if we say if this is not set, right? If this is not set, then we'll do the transition. Okay, because if it is set, that means the previous action we had updated had set a state transition. So we'll just say that the idle or standing or jumping state transition, it has less priority than what the individual states have queued up, right? And that's going to work for now, I think. And generally, it's a common strategy to take. Now, reactions will not check that transition variable because they override any actions that, say, the player made. So let's look at this again. Going through here, get to the final frame, press the button. I'm still going through idle. So what's going on with that? What did we mess up here? Let's go check this out. So I was expecting that to work, to be honest. Let's go back to our common states here. So actually, first thing of all, since we're going to be calling this all over the place, I want to get rid of this and put it in the common state transitions. Okay, that's I think that makes sense. Okay, that yeah, we have action A data. I don't even know if we need to check that. I think honestly, I forget why I specifically did that in the first place. But anyway, I probably want to change this. Let me go up here and put this in the first place. Okay. And honestly, what I'll do instead of greater than or equal to duration, I'll say, then I'll return, so we don't do anything. So we're going to skip all that stuff. Okay. Okay. In the future, we might actually support transitioning these things on earlier frames if there's special properties, but for now we're leaving it like this. This will give us the option of supporting that later, but yeah. Okay, so I'm going to move this out of here because I don't know why I actually have that action data check. It was something we were doing earlier on. But yeah, okay, let's just double check that wasn't the bug. Okay. Whoops. Oh, because undeclared identifier action data. Oh. Gotcha. I know why I did that. We did that. Okay, now it makes much more sense. Okay. I just missed that entirely. So we need to have the duration from the action data. Gotcha. Okay. Okay, there we go. That's why that was there. So that's probably not the bug. We're probably going to have to actually look at... What are you doing? Unused capture. Oh, right. Cool. It is unused capture. So actually we don't need this at all. That actually fix another bug that could potentially happen. Now, you should always have action data, but... And also, just to show what happens here, that means ground collisions are going to prioritize any actions we take. So if you're doing a jump attack, you won't go into the jump attack when you hit the ground the same frame, and you press this button. It's going to be the landing. So again, we still get a frame delay. Now, what's going on there? Let's do this one more time. I'm going to check something. So we do have a bug somewhere that's preventing us from going through into the action. So frame 1, we can see we go through this pose, right? Now the question is, where does the delay come from? When I just press the button and frame step forward, it always directly goes into this action. You can see this, right? I pause it, hold the button down, step forward, we get this. But when we get to the final frame, we expect the same thing, yet I get the idle through here. So what's going on? Well, let's just debug it real quick. So that will make it, make it obviously clear why we're not hitting this. Okay. So get to the final frame. That means the next update, we're going to go through this game loop here, right? So let me move this over here. So what do we expect to happen? Well, what we expect to happen is we actually call this function, right? This common idle transitions. We should call this function, and we're not getting there's breakpoints. So if I step one time, we expect this to be called. So let me step. And we do, right? Okay, and we should hit here if I continue. And we should be able to like not return, right? We should pass through this. Oh, we did return. That's interesting. So what's going on there? Let's look at our context real quick. So what are we checking here? We're checking the frames elapsed, right? Frame elapsed. That's in the timeline component. Frame elapsed is 19. And then what is our action data? What do we have for duration? It's 20. So that's why, right? And I think what we'll see here is we'll jump here where the on update happened. It's because we're updating frame elapsed after the state has been updated. Now, a quick fix is to add 1. But on the other hand, we have to consider, why did we do this in the first place? Why did we put the frame elapsed being updated after the action update? Honestly, I can't remember any specific reason why we did this. So for now, let's just say the frame elapsed will be up here. This allows us to respond in the individual state update functions. In the individual update function. No, Melon, man, it's not because of that. It's because we were updating the frame elapsed after the update function. So the consequences that we have here are the first time we run the update function the frame elapsed will be 1, not 0. Whether or not you think this is rational, logical, it's not really the point. It's more like you just need to know that's the case. So on first frame, you'll say 1 while you're in the update function. So these things you have to consider. What are the trade-offs on code readability? What assumptions people will make, or you yourself will make, right? Okay, so that should fix it, at least for this situation. If we check frame elapse from on update, we need to assume that it starts from 1, right? And the final frame will be equal to frame duration. Okay. Oops. Did we hit a breakpoint there? Oh, yeah, we did. Let's do it again. Okay. So we're on final frame. Let me hold the button down, and it fixed it. We're back to this. Okay, so that's all well and dandy, but let me show you something. Let me hit the character here. Actually, we had input for the player 2, right? Well, I thought I supported player 2 input. We didn't support player 2 input, right? I thought I did at some point. Maybe I'm losing my mind. Let me jump down here real quick. Pull gameplay. Yeah, so I have pull. So I have to have a second controller. Give me a second. I thought I supported keyboard though. Yeah. I'll only support a keyboard for player 1. Okay. Sorry, I'll support that later. Let me plug in another controller. Give me a second. One here, I thought. Yeah, that worked. Okay. Is it gonna work? It's gonna sync. There we go. All right, so I should be able to control player 2 now and show you what I'm talking about. Okay. And it's just going wild. I think my controller has not been sync. Okay. Yeah, look, it's going crazy. It's completely. I don't know what it's doing. Oh yeah, I think I had this issue with this controller before. Let me find. Let me see if this works. The PS5 controller. Okay. I'm not sure if this library supports. Okay, that works. I'll use the PS5 controller. So what I want to show here is, or what I want to demonstrate. Where's my other controller? That's fine. What happens when I'm in hit stun, right? This is something you have to consider. So hit stun. Get to the final frame. Same kind of situation. What do I expect? I expect to hit a button and go into an action or jump or whatever. So hit a button, frame step. I don't do it. It takes 2 whole frames. 2 whole frames to get into my action. Let me show that again. Okay. All the way to the end. I'm going to press the button here, right? Hold it. We go through this weird transitory something state. Back to idle. And finally attack. That's not what we want, right? That's the worst. You're getting an additional 2 frames of recovery when you don't need it. So what's going on there? Well, let's go to our reaction code, right? It should be in our common states. We should have the reaction. So how do we transition here? Well, we don't actually do the transition on here. We do it in our reaction system, right? We could have put it here. And honestly, if we want to fix that bug, let's do this. So we'll take the common transitions function, put it in a reaction. This is one way to fix it. There's other ways we could do it. You go to common reaction states like this, and put in the context. What happens if we just drop it in there just to see what are the consequences, right? What do you think is going to happen? Okay, well, let's get attacked. Go through our reaction here. Let me hold the button, nothing here while it's happening, which is what we expect. Last frame, nothing, it doesn't do anything. The problem is we're checking to see if, we're checking to see if the frames elapsed or less in duration, right? But we're in a reaction, the duration is set in the common action data. That's like a fixed value. So we want something more set up for a reaction. So let's just say common reaction transitions. Okay, let's just call it that for now. And we want something similar. So we're just going to copy and paste this code. We're going to move all these input transitions into something else. We're going to move this into a new function. Let's just call it common action. What? Common transitions. Okay, let's put common transitions for now. I really don't have a good name for it at the moment. Do that. Put that there. And we're going to take common transitions. Oh, we need the context, right? So let's take the context. And we need common transitions from here. Context. So we're doing it from this previous function, so that should work. And then we're going to paste this into here for now to see what happens. So, and instead of calling the common idle transitions, we're going to call common we're going to call this one, right? So if we run it, what happens? We're forgetting something, right? That's clear. Oops. So what was the error here? Oh, wait, return type. Okay. I forgot void. Okay. Okay, back to the drawing board. Let's get hit real quick. What if I hit a button in the middle of it? Oh, I can transition now. That's not great. We don't want to be able to cancel out the reaction, so we need to actually account for hit stun. Now, how do we deal with the hit stun? Well, in the reaction system, we have that transition, right? So we have transition set up like this. When hit stun is less than or equal to 0, it's something like this, right? We have to do this kind of check. Here we just go back to standing. Okay. But this is going to be something that's going to catch us, right? We see that hit stun less than equal to -1 means it's reducing hit stun here and then doing the transition here. Okay. So we could move that transition code to here if we wanted to, right? This is something we could do. This would make it very clear we're either going to go into a attack, or we're going to go into idle. Okay, so for the reaction system, this is just going to demonstrate another way to do this. We don't necessarily have to transition out of each action. That means we don't have to account for every single potential future reaction state that we create. So as a demonstration, we'll do that. This is a little different than we did before, which was where we specified the transitions inside the states themselves that we're running. That was for the attacks. For this, we're doing for the reaction. There's just two different ways we could do this, right? We could do it from a global system, or we could do it from the local state handling code. So going back to our, let me even have this open yet. So the one thing that will happen with that though is, let me show you. Back to our common states. So we have this function. It's not a public function, right? Handle collisions. So sorry. Yeah, so it's not a public function, right? So we can do this, right? We've already imported, I think, the common states in the reaction system, right? Because we are well, actually, I don't know if we included it. So what we can do is, instead of putting these common, so we could separate this stuff. We'd have to separate these transition functions into other places. Or we can just import common states. That adds a dependency. I don't think it's here yet. Yeah. Hold on. where have we included this? It's the common states file. So far, only in the game state and the game simulation. So just to demonstrate what we're talking about here, we can go through and refactor and make this better later. But what I can do now, instead of doing this like idle check thing here, we can do common states. Oh, well, it's not doing that. Common reaction transitions, and then pass in the defender's context, right? This should be the context that we pass in the state machine. And instead of doing this, it's going to be handled in here, right? When hit stun is 0. So we can get rid of this. And we have to make sure to get rid of also the call from our common states function, right? So, oh, sorry, common states state callback, update callback is what I mean. Okay, where is that at? Again, common states. Okay, cool. So yeah, we have it called from here. What is it? Yeah. So get rid of it here, and let's see how that works. Oops. Action states. Expected type action state, state machine state, combat state context. Found action state, state machine combat. Oh, it needs to be a pointer. Okay, sorry, that's the problem. Let me pass in the pointer. Pass in the address, and for address. Let's think of it that way. Okay, so let's try this again. Let's attack our guy. Gets hit. I'm gonna press a button to make sure we're not transitioning out during the middle of it, which is cool. Get the final frame, press the button. So instead of going through 2 frames of delay, we only went through 1. Let's see what's going on there. It must be something with our hit stun system being not set up correctly. I think we've actually discussed this before, what the issue is, but at least we got rid of the 1 frame delay. So get down to the final frame. Here we're at. Press the button. So we can see we have 1 frame of hit stun here. So that means the next frame should be back to idle or attack. Oops, I hit 3. Wrong one. Let's do that again. Get through hit stop. Go all the way through here. Get to final frame. Hit a button. Step. We have this extra additional weird thing here, right, with a bunch of extra frames. And then we go through it. So what is going on there? Really, what's going on there? It's just the kind of stuff you have to be very careful when you're making fighting games. You can easily overlook if you're not really paying attention to this whole frame advantage thing. So we go through an extra like kind of virtual frame, and then we go back to idle. Oh, if you're not doing anything, you just keep going through this. That's weird. That's an even worse bug. Okay, so what's happening? I think I know. Basically, let's go into our game simulation reaction system, right? Look what happens. A reaction system is the very last thing we do, right? The action system, which handles our transitions, it's there, right? It's before the reaction system. Now we could run the reaction system first, but then the reaction system can't respond to collisions. Okay, so let's run the collision system and the reaction system before the action system, right? This does our state transitions. What happens then? What are the consequences? Well, say this frame we transitioned into an attack. That's fine. What if it's active frame 1? Let's just assume that. Well, if it's active frame 1 and it happens after the collision system, that means it doesn't check against collisions that frame. It means it will be the next frame, right? So we'll go through, and then we'll see a reaction the next frame. Now, if you play a lot of fighting games, this might sound familiar, right? You'll see like an overlap of hitbox. on a particular frame, but then you update, and then you'll see the actual reaction happen. You'll see hit stop start, hit stop start. The way we've set it up here now is it's the same actually. Well, the problem is though is the reaction system is delayed an additional frame because of the way it's ordered with the action system. It needs to be before if we want the transitions to happen this frame. Okay, so what do we do? And that's another thing. You can't respond to the physics system update either. So do we move the action system to the very end? This is just something to consider real quick. So let's move it to the very end. And is there any other consequences we have to worry about? Yeah, so the debug tools are very, very critical for looking into these things. If I didn't have those before, it's much harder to debug. So yeah, you just move around just fine and everything, right? Everything's moving. Everything's good. Okay. Let's just test our whole thing where you step through. I hold a button on this frame. And we go next frame we go directly into attack. So that works just fine. Our action system kind of works in that way. What if I attack? Actually, let's turn on hitboxes. Is that F4? So we're active on this frame. And we go into the reaction. Let's check that again. So this frame, you can see the active box is here, right? But there's no reaction happening. We're still, well, it's kind of a bug here. Hold on. Okay. All right. It doesn't handle looping well. Okay. On the debug display. So we get to the active frame. We're still in idle. You can see clearly here player 2 is in idle. Previously, when this happened, we actually saw the reaction happen in the same frame as hitboxes and overlap. If you look at other fighting games, this is what this looks like, right? Like this is kind of like the effect you'll see in a lot of other fighting games. Then you step one time. Now we're in our reaction. You can see the 25 or so frames at the bottom. Step, 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 step all the way through. Get to the final frame. Hold a button. And we're going to our attack. So that fixes that. Now, there is consequences here, right? Like I said, the frame you see in attack become active doesn't show the reaction happening, right? It doesn't happen on that same frame. Now, since we have something called hit stun, it doesn't really matter. Like, we are applying hit stun. Sorry, not hit stun. We have hit stun, hit stop. So we have hit stop that gets applied the very next frame. So we're not transitioning another frame. Let me show you, make this clear. So when it comes to like frame advantage, as far as the two characters go, this doesn't affect it. You saw when I frame stepped there, it didn't advance at all. Frame elapsed didn't advance at all. Let me show you again. It's kind of like a virtual frame, right? Let me attack again. Where frame elapse is at 8. Nothing's happening yet. Next frame elapse is still 8. We have hit stop. Get down to 0. Frame elapse here is 9. Frame elapse here is 1. This is a count of frames that have elapsed. There we go. So that kind of works exactly what we expect. Now, maybe you can think of it as a downside, but many fighting games do implement it this way because they're very simple, kind of like feedback loops, right? Of transitioning and between the transitions and the hit stop and stuff like that. I'm sorry if that wasn't very clear, but you could think of things as a feedback loop, right? The things you just did will affect the same systems over and over and over again. What are the alternatives? What could we do? Well, we could have two transitions, right? We can see here, we have the action system being called here. Is one thing we could do. We could call the action system first before everything. Do our base transitions and then do collision checks. Then execute reaction system. And then we could do another transition. We can check to see, oh, it has any special, if there's special reaction transitions that have been triggered, or there's any additional transitions that have been triggered after reaction system, then we can execute again. I've implemented this strategy in multiple games. It's fine. It doesn't really matter so much how you do it. It does just kind of adds an additional 2 places where transitions occur, right? Yeah. So it's just however you want to look at it. There's probably other strategies as well for handling transitions. If you really want to see hit reactions happen in the same frame a character is hit, you can do it. It's possible. I might demonstrate that later, but I think this is a good for now. I think this is a good demonstration of a kind of like classic fighting game implementation, and the side effects and kind of the weirdness, quirkiness that you see out of a fighting game. If you ever pulled up a fighting game in like a debug tools, like in SNK King of Fighters or something, there's like debug ROMs, and you can actually frame step through stuff, or you just do it in a emulator, right? You'll see like the frame that's supposedly active on the opponent's not going through a reaction. The next frame you'll see hit stop, and you'll see hit spark. Sometimes they show the hit spark the same frame, right? Again, the consequences are the action system updates the timeline, so you don't technically get the hitbox, even though it's showing you that frame, the hitbox, right? You're not technically checking it that frame, right? You didn't check it that loop. What you're seeing is kind of like, how do I put it? So for example, you input something in this frame. It doesn't affect delay on input because you input something in this frame, and it will show it immediately, that frame, right? Because we have the action system over here. If we put the action system before input command system, then it'll be delayed a frame, right? That's not great. But these kind of like 1 frame delays, you have to really, really carefully think about. But yeah, so your action will come out the same frame. But again, doing the thought experiment, if you have a active active first frame attack, you press it and you frame step, you see the attack come out, but you don't see reaction, right? This is kind of what we expect. We see the reaction next frame. But the character will still be on frame 1 the next frame because hit stop. Because the next frame, what happens? We do the second update. So the first frame, we see the action come out because we did an input. The action system executed. The reaction system, collision system didn't matter. Next loop would come through. Oh, collision system's here, so that gets executed on it. Reaction system's here, oh, that gets executed on it. And then all the transitions happen, and then you see the reaction, and you see hit stop, and blah, 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 blah. The action system won't, as long as they're hit stop, the action system will not update the timeline. Okay, these are things you have to be very careful to think about, right? Again, you can rewrite this stuff so everything just kind of happens on 1 frame instead of like thinking in like 2 frame loops. Just the thing I just want to point out and make clear is the way we've implemented it here is collision will not be checked until the next frame, but that's fine because it occurs before the action system does any state transitions. So we go into a hit stop and prevents things like skipping over, say, a collision box or something. That won't happen. Effectively, the collision checks the previous frame's update. Now, if you want everything nice and tidy, you can do everything on the same frame. You can do that with 2 transitions. That's one solution. And again, I've seen games that do this. So yeah, up to you. But that's pretty much all I have for today. So if there are any questions, go ahead and ask. Otherwise, I will start shutting down and get ready for work. Speaking of which, sorry for the last few weeks. We got TGS, had to meet some people, and suddenly I got thrown on a new project and had to deal with that. So that's going to add a little bit of chaos to my timeline for now. Yes, so that's trade-off. There's always a trade-off, right? Adding another transition will add more complexity. It adds more things you have to think about. But is it more complex than calling the collision system the next frame for the thing you just the thing that just became active this frame? That's kind of up to you to decide, right? it's it's basically the same kind of, if you really think about it. Loops, it's more code, of course, but we're still talking about kind of executing in the same order, right? Um, we just don't have that nice we don't have that nice frame discreteness between the transitions. We could potentially have two transitions per frame. Another thing you could do is you could add a check like, okay, well, I won't talk about that part. What are we gonna do next time? Well, let's just go ahead and mark all that stuff done. Where is it? Where is our schedule? Our planning. So, yeah, I'm just going to mark this stuff off as being done. And then action time it doesn't determine return idle. Hit stun will. We've already supported this, so I can get rid of that. Actually, I think that's a bug we still need to look into. I'll need to check that. I'll look at that offline and see if I can do that. Support input to, we already supported that. I'm just gonna, that's sometime I did that some other time. Hit trades cool. Launch reaction, launch physics, avoid reloading textures, block reaction, block stun, but hit properties and character data. Okay, I don't know what we can do next. I'll think about it. I really want to do very fighting gamey kind of like quirky things. So like this frame boundary kind of issues. Yeah, anyway, that was cool. I hope I was able to explain something in a way that y'all could all at least understand at some level. I know sometimes I kind of go on tangents just a little bit. But yeah, until next time, I hope you all have a good evening out there in the US. If you're there in Europe, well, I guess it's very early in the morning for you. Out here in Japan, we're all going to work, so I'll do that, get a little bit of breakfast, get some more coffee. And get going. Well, until then, see you soon. Peace out.